is a podcast for question 4 of the classical mechanics coursework. And question 4, what we have is now the beginning of trying to solve this set of equations for lambda not small and lambda not equal to 0 but lambda equal to 1. And we can do that by changing coordinates. And changing it in the following way: u is equal to x minus y over root 2, v is x plus y over root 2. So if you remember from second year, if you did systems of ODEs, you probably looked at first order ODEs, you could do a coordinate transformation which made them easier. It's essentially what we're doing here. So question 4 is basically asking you to do this coordinate change. First of all, we'll describe what the coordinate transformation is in words. Well, I can write the new coordinates u and v in terms of the old coordinates in terms of this matrix. And if you remember from, well, first year, what the rotation matrix looks like in 2 dimensions, it's cos theta minus sin theta cos theta. So we make a comparison between that rotation matrix and what you're doing to the x and y coordinates. Then what you find is that upon comparison, if you set theta to pi by 4, then you get exactly the same matrix. So it's equivalent to a rotation by pi by 4, and this matrix is for rotation anti-clockwise around the axis. So that's 2 marks, 2 of the 4 marks for describing that in words. Rotation pi by 4, anti-clockwise. And then the other part of the question is to rewrite the 2 second order ODEs in terms of u and v. Now, some people made quite a hash of this. I think everyone got the right answer in the end, but it's not that difficult. It's just, you just put in u and v into those equations. You differentiate u with respect to time twice and v with respect to time twice, and just insert them into the equations. You should get the right answer. An alternative is what we're doing here, which is to just add the equations together. You add equation 1 and equation 2 together, then you're going to get x double dot plus y double dot on the left hand side, and everything you get on the right hand side is also a function of x plus y. So you can write all of this as the second differential of x plus y is just factorising the right hand side minus 1 plus lambda times x plus y. But we know x plus y is root 2v. So if we just divide everything by root 2, left and right hand side, then we're going to end up with v double dot is minus 1 plus lambda times v. Then, instead of adding the equations, we can subtract them. I'm going to find that if we subtract them, then we can write everything here on the left and right hand side in terms of x minus y. And I think this was really the quickest way of just rewriting these 2 equations in terms of u and v. Just to recognise that to get the left-hand side in terms of u and v, you just add and subtract the equations, and then everything else just falls out. So rather than, some people spend 2 or 3 pages just trying to rearrange these equations, and here we're doing on 4 lines. And so if we do 1 minus 2, then we see factorising the right-hand side, we basically end up with the equation u double dot is minus 1 minus lambda u. So this question was worth 4 marks. Where did the marks come from? Well, 1 mark for saying that the rotation is pi by 4. 1 mark for saying it's anti-clockwise, and 1 mark for each of the equations. That's 4 marks.